Hello everyone. Today we will discuss one of the important subject in computer science and engineering. Before that, let me discuss some basics with you. You might have used one word very often in your day-to-day activities. Whenever you take a selfie of yours, whenever you take a picture of your parents, whenever you take a picture of your friends, whatever you get, that is a photographical material. That is nothing but an image. So what is the definition of that image? What type of images are there? How images can be observed? All these things we will discuss here. An image is a visual representation of any object that is produced on a photographic material. As I told, whenever you take a selfie, whenever you take a picture of your parents, whenever you take a picture of your friends. Okay, so that object whichever you are going to capture, that is a photographic material. Or it might be on an electronic device, like your cameras of your mobile phone, like a cameras of your laptops, a camera of your webcam. Whatever the picture that is going to be captured by these devices, that is your image. The images are of two-dimensional and three-dimensional as well. The two-dimensional images are the photographic images or a screen display. The monitor which you are able to see now is a two-dimensional image. A statue, if you go and observe, it is a three-dimensional image. What are the objects which are going to capture these images? It might be a camera, a lenses, a mirror, telescope. These are all the objects which are going to capture the picture, which you will call it as an image, which are two-dimensional in nature in a broader sense. Whether these are the only objects which are able to capture the images? Not necessarily. You have eye. You have one natural object called as human eye, which can capture the images and it can process it, send it to the brain. With this knowledge, now we will put up an image as a broader sense, as it's just a two-dimensional image. It might be a map, a pie chart, a painting, or a banner as well. Images are usually of two types: analog images and digital images. Analog images are of less interest to us. We will directly go to digital images. When was this first digital image was formed? Before that, how was the situation? A point of a discussion here. Before digital image was formed, there was an image being transferred between London and New York. That was through submarine cable, and those analog images, to reach from London to New York, it was taking more than a week. During that period of time, in early 1920s, the first digital image was formed. And they formed using a system called as the Bartlett Cable Picture Transmission System. This Bartlett Cable Picture Transmission System was invented by two British inventors, Bartholomew and McFarlane. They developed the system in the early 1920s. As I already told, the images were sent by a submarine cable between London and New York. And I also have told you that the time taken was more than a week. During that period of a time, the introduction of this Bartlett Cable Picture Transmission System made a change in the history of images. The first digital image, which was produced in early 1920s, started to be used in the first industry called as the newspaper industry. The first application of a digital image was in newspaper industry, when pictures were sent by a submarine cable between London and New York. Specialized printing equipment coded pictures for cable transmission, and reconstruction of them was happening at the receiving end. Then what was the first historical image that was being transmitted? Here, have a look of it. This was the first image which was being transmitted, and it was reproduced on a telegraphic printer fitted with typefaces simulating a half-tone pattern. Telegraphic printer faces, you have been aware of it. Then what about this half-tone pattern? Have a look on this. You are able to see a set of dots on the left side of an image, and the gradient of the image is put on the right side of it. This system was used on the receiving end for reproduction of the same image. Now you observe there are set of dots which is being put over here. Okay, so these dots are of varying intensities. Some dots are very small in intensity, and where some of the dots are very high in intensity. When I take a gradient of these intensified dots, you are able to see the image which is on the right side of it. This can be observed either by gradient application. So here what happens is, when these dots is being moved, when a person starts from a certain distance and he observes this image, it looks something like this. When we take this example, you will be much more clear with this. Have a look of this example, please. You are able to see the dots are of different intensified here. Some dots are very less intensified, and some dots are very high. If we want to clearly observe, you have to move certain distance and observe this image, or else make your eyes very smaller enough and observe the images, and the image very much clear that it is an image of an eye and a nose of a person. So this technique they started using, and you are very much clear here that they are using a gray levels here. In early 1920s, when the first digital image was formed, it was making use of 5 distinct gray levels. Later that was improvised. The capability increased to much more levels of gradients. We will call it as a 15 gradient levels. We will look that in a considerable slides. Now have a look of the Bartlein transmission system here on the left side. On the right side, you are able to see a picture that is being transmitted and received at the system, at the Bartlein transmission system. As I already told, the Bartlein systems were capable of doing images or capable of coding images in 5 distinct levels of gray. This capability was increased to 15 levels in 1929. So, we were able to increase the capability of the gray levels. That means whether we are doing image processing here, might be. But our discussion of digital image processing is intimately tied to the development of digital computers. As and when digital computers kept on improvising, digital image processing also went hand in hand with the growth of this digital image processing of digital computers, from digital computers actually. So we will discuss digital image processing. Myself, Professor Shashidhar, and my colleague Professor Hanaraju B will be giving a lecture series on digital image processing. Let us get back to the flow of our understanding of digital image processing with respect to the history. So we discussed that in early 1920s, Bartlein cable picture transmission system started to first produce the digital image. In early 1920s, it was used in the newspaper industry. Later, when the capability increased to 15 levels of gray, then it was in the year 1929. So later what happened? In early 1960s, okay, the actual image processing was carried out by digital computers. The step which was taken in 1960s that paved a way for image processing for long distances. Ranger 7, which was being put on, started to transmit the images of a moon. Those images were received at a Jet Propulsion Laboratory in 1964. Image processing of that image was much required, where the first step of image processing being started. The image which was sent by Ranger 7 and which was processed at the Jet Propulsion Laboratory were looking something like this. You are able to see an image of a moon that was being transmitted by Ranger 7, and it was received at the Jet Propulsion Laboratory. After processing, this was the image looking like. The image processing techniques that was being learned in this laboratory paved a way for much more processing in the space machines. We also called as these imaging lessons helped a way to serve the other space machines. This was in the year 1964. Later in the late 1960s and in early 1970s, the digital image processing began to get used in medicine as well. In late 1960s and early 1970s, one scanning system was invented called as tomography. It was a technology behind computerized axial tomographic scans. This tomography was invented by Gottfried Honsfeld and Professor Alan M. Cormack, who shared the Nobel Prize in Medicine in 1979. When a digital image processing was being started to use in medicine in late 1970s to early 1980s. So from 1980s to late till date, whatever you are observing now is a image processing techniques which has been exploded like anything, and now in all kinds of areas digital processing is being used. Then what are the areas where you can observe now in a digital image world which is digital image processing? Let me put a light on areas of digital image processing. Medicine. Medicine is one of the important area where a digital image processing was used. Have a look of the image, please. You are able to see. Just concentrate on the mouse pointer. I'm just pointing on a medicine and image enhancement. Now you concentrate on the mouse pointer which is pointing to the left side of the X-ray images. Okay, so now have a look. So this is an X-ray image of a person's rib cage. You are able to see very uncleared form of your heart, an unclear form of a rib cage bones. Okay, at the bottom of the heart, what is being present? Whether the bones are still existing here? No, we are not able to see. You are not able to see the curvature of these bones because there might be a fracture of the bones at the curvature ends. That's very not clear in the medicine X-ray images. When we go for medicine's image enhancement, when we go for digital image processing technique being applied here, you are able to see the images which are on the right side. You are very much clear that below the heart, that was our first discussion, below the heart there are set of bones as well which are protecting our heart. Very good enough. Very much clearly you are able to see the curvature of the bones which will help us to identify any fractures in these bones as well. So in this way, digital image processing started to help the doctors to understand the process of any problems in our bones or with respect to any part of our organs. Let me put, not only in animals, not only in humans, image processing is being used in animals as well. Have a look here. You are able to see the original MRI image of a dog's heart. So if you want to know what is the shape of a dog's heart, you need to apply the object detection. You need to apply object detection technique where you will observe the shape of the heart very much clearly being observed. You can tell that yes, this is the shape of the heart of a dog. Next area. The Hubble Space Telescope is a space telescope that was being launched into the lower Earth orbit in 1990. Okay, the image which was sent by that telescope was looking something like this, which is you are able to see on the left side of it. This image is very much not clear to the scientists who are going to observe the images. So they started applying image processing techniques and they are able to get the image which is on the right side. It's very much clear here. They are able to clearly observe the stars, the actual picture, the actual shape of the whatever the image which was being sent by the Hubble Space Telescope. This is one of the areas where digital image processing is being used widely. We'll move ahead with the other areas. You are able to see the artistic effects here. Let me put up here. Good. You're able to see the artistic effects of a movie called as Bahubali. In a movie, we are able to see the green background which has been put up here. Using a digital image processing technique, I can remove up the background of the image and I can replace that with the image which you are able to observe at just the bottom of it. With this, it is very much clear that this green screen can be replaced with any of our interest. You can do this once you started using your digital image processing in your day-to-day activities as well. You do it. Whenever you take an image of yourself, okay, if you do not like your background, you have always the option to change your background as if you have been sitting in some other country or some other place. The same technique, one more example, in the same movie, we are able to see a person carrying a baby and moving here. At the background, you are able to see a green picture, a green screen that is being replaced with the image which is of interest of a director. This way, digital image processing is used in artistic way also. Digital image processing are also used in geographical information systems. When the image is being taken by the satellites and sent to the scientists, they can clearly predict that the hurricane or the cyclones which are going to enter into USA or Canada here. Usually they do not call cyclones in USA, they call it as a hurricanes. It's very much clear that at what speed these hurricanes is being entering into USA and what part of the America might get damaged can be predicted using these digital image processing techniques. One more important area I'll just put up here. Your industrial inspection. Whenever you take an X-ray image of your laptop, there is no need to open the laptop and observe where the error is. The X-ray images will give you the picture of an internal structure of your laptops. That can be given for digital image processing technique, and that technique can help us to identify what part of the image is being damaged. Whether the capacitors, inductors or a fan of a laptop is being damaged, that can clearly be observed here. This is one more industrial application where digital image processing is used. Here, whether the tablet is being properly induced or not, whether any problem in the induction of your tablets is clearly being observed. You can also see one more application where the bottles need to be filled here. Any bottle which is one more application where a set of bottles need to be filled and being sent for delivery of the products. Here you observe that when this type of image is being transmitted, the image processing technique tells us that the third bottle or the mid bottle is not being filled and need to be discarded, so that this will help for customer satisfaction. There is one more here, a target of our interest. In a pipelines which has been put over here, any pipeline which has a damage can clearly be observed in the inspection of these digital images. So these digital images can also be used in the PCB inspections also, as we have discussed now. Apart from this area, one of the very important area where digital image processing is used is law enforcement. Nowadays, the law is every person who is being traveling outside his house or who is going to come out of his house should compulsory wear a mask. You're able to see some set of persons who are not wearing a masks. So these images, these persons' pictures, this face recognition of these persons can be captured using digital image processing technique. And a proper fine can be imposed on these persons who are not wearing a mask, who are not following the law. The same thing, when a vehicle is moving at certain speed, we will make sure that the vehicle should move with a speed of 60 to 80 kilometers per hour. Suppose the driver crosses 80 kilometers per hour, digital image processing can capture the number plate of that vehicle and send it to the department so that they can take a necessary action. Digital image processing can also be used for fingerprint recognition, face recognitions also. In a forensics, they can identify any object which might be harmful there. A room which is under consideration, if you take a picture of it, give it to digital image processing, it can tell that any harmful weapons available at that place. Digital image processing can also help for any suspicious movements of a person or suspicious behavior of a person can be clearly observed or clearly analyzed using digital image processing. In agriculture also, digital image processing is being used. The pH levels of a earth or a soil can be observed. If a pH level of a earth or a soil which is being under consideration is very high, we suggest the farmers that they do not produce any farming cultivation, they do not go for any cultivation there. If the pH level is mid enough, we can guide them for a suitable crops, and if the pH level is low enough, we will guide them which crops can be helpful for them and they can get a good yields from that. In this way, digital image processing is being used in almost every areas of our day-to-day activities. With the understanding of this, we will start to know in the coming semester what all the topics which we are going to learn and which all the topics are under consideration for us. So your subject code will be 17CS753. The syllabus goes something like this. In the first module, you will be learning about the fundamental steps in digital image processing, the components of a digital image processing, and sampling quantization method, representing, how do you represent a digital image, okay, and some basic relationships between the pixels and neighbors you are going to learn. You're going to learn the connectivity of the pixels in an image, application of that image processing in a medicine image, and robotic vision, character recognition, and remote sensing. In the coming modules, we will discuss about the histogram images. The histogram images of a dark image will look something like this, and how I can make use of this type of graphs which has been observed for image enhancement, that can be discussed in the coming module. The histogram image of a light images can be clearly observed, and how that the graph is being clearly seen here, and that will help us for image enhancement. The same thing for histogram of a low contrast images and a high contrast images. So basically we will learn about the histogram images. We will also learn the arithmetical and logical operations being carried out on the images. You are able to see an image, okay, an image on this side, and you have one more image. If I go for a logical operation or arithmetical operation, if I make an AND operation of this, I am able to pick up only the area of interest in my image. I can display it here. So I am making this image and I am taking this as a second input image, and I am making an AND operation of this, and I am going to observe this image here. The same thing can be observed here as well. This is one set of image, this is the second image. If I make an OR operation of this, and I am going to select the area of interest. Here the black part is being imposed on the image and the white part is being ANDed here. And same thing here, the white part of the image is being imposed here and the black part of the image is being superimposed here, and our operation of that is being collected here. In this way, we can apply arithmetic and logical operations for digital image processing. So in the coming discussions, we will concentrate on the spatial filtering of these images. You are able to see the image which is on the left side. This image is being captured. So we will go for blurring of these images. The reason for going for blurring of the images is the small dots which you are able to observe here, these are not of our interest, because these dots does not provide us any information for analysis of it. We will go for blurring of the images, and after we blurring of the images, the small dots is being disappeared. How this blurring of the images will be done, we will be learning in the discussions. Just put a light on that. These small dots which you are able to observe, that will get on the surrounding pixels. We are going to take a gradient of it and we are going to get these type of images. In a detail, we will discuss in the coming modules. And after I get these blurred images, and I'll apply the proper thresholding system, and I'm going to get this type of a clear picture which is our interest, and these 8 dots will help us for analysis and retrieval of any information which can be observed. Next, sharpening of the images can also be done. That might be called as a sharpening filtering images. This original image which you are able to observe, I am going to apply the Laplacian filtering image. This Laplacian filtered image, when I observe, you are able to see the output which is being observed. It's a very sharpened images. The craters which you are able to see on this image can clearly be observed here. It might not be very much clear on these slides. You can get back to your text, or you can Google the images of sharpened filtering images. You can clearly observe this. This sharpening of the images is quite reverse to that spatial filtering, where there blurring of the images is being done. Here deblurring of the images is being done. Those two techniques, if you combine, we will get a combination of it, and when a series of steps is being carried out, if this is the image which is being observed, you can get the image very much clearly here, and these images will help for the doctors for analysis and retrieval of any information which is of the interest. In the further modules, we will discuss about the transforms. If any image, if I put it in a graphical form of representation, it looks like this. This is the input beam of a profile picture which has been received by us. I'll apply the higher spatial frequencies and filtering frequencies for this Fourier transforms of the mathematical expressions we are going to apply here, and I'm going to get this output beam. And you are able to observe these distortions which you are able to observe in the input beam is being clearly removed at the output beam. Such type of mathematical calculations we are going to learn in the coming modules. Also, we will learn about the edge detections. You are able to see the flower, okay, and you are able to see the petals here. What is the shape of the petals? If you are interested, you can go for edge detection. So after the edge detection, you are able to see the image which is on the right side, which is capturing the edges of that flower. This one is edge linking. This type of a processing technique will help us to identify where actually the number plate is being present of the vehicle, and concentration of that area which help us to identify the number on the number plate. Also, we will learn about the line detections in the coming modules. These line detections, whenever this image is by input for you, if you want to detect where actually the lines are there, you are able to see this type of images. The output image is very much being clear that it is identifying or detecting the lines present in an image. Also, we will learn about the split and merge of the images. So if this is an input image which has been given to you, after splitting and merging of the images, you will observe this type of images which is much clearer than this, and after apply the thresholding of the images, a very clear and sustained images can be observed here. In the fifth module, we will learn about image processing as well. With respect to compression, we will concentrate on the fifth module. So with this type of a historical background of the digital images and also the areas of digital image processing and what we are going to learn in the coming days of digital image processing is being discussed here. In the coming class, we will discuss of how fundamental steps need to be carried out for digital image processing with the introduction of digital image processing. Thank you.